Good evening, everyone. I hope that you are doing well. Just checking whether we have to wait a few minutes or we shall start immediately. Give me 1 minute. Thank you. Good evening, Mohammed. Okay, I think we are good to go. So first of all, I would like to introduce myself. My name is Ahmed Medhat Abu Ghida. I'm a certified Lean Six Sigma Black Belt from Quality America, the AUC, certified Lean Six Sigma Master Black Belt from the International Quality Federation, accredited training associate from the International Association for Six Sigma Certification, the IASIC. Terms of training, I have been teaching Lean Six Sigma since 2010. So I have been teaching Lean Six Sigma for more than 16 years, working with the American University in Cairo and many other organizations like Pymerstan, for instance. In terms of education, I hold the Master of Science in Statistics, Mathematics, and Operations Research from UK. I'm Data and AI Senior Consultant and Lean Six Sigma Mentor at Dell Technologies, Dell US, since 2021 till now. I'm afraid the number is high, so we don't have time for you for each one, to loop over each one and introduce yourselves. So usually when the number is low, 5 to 10 maximum, I will go through each candidate asking him or her to introduce him or herself. But I'm afraid, given that we are 22 participants, this will take a lot of time. So this is something we should avoid to avoid wasting a lot of time for introductions. I would love to, but it would take a lot of time. Anyways, our course is called Lean Six Sigma Yellow Belt for English speakers. So the main language of teaching will be solely English, unless in specific situations when there is complex term which doesn't have a corresponding alternative in Arabic, or I will limit it to English. Specifically, in some situations, I will do some translations, some analogies uh, in Arabic to make things more clearer. So we are not 100% strict to English. Feel free if something is not clear, please say it in Arabic, and I will be more than glad to translate it or explain it even in full in Arabic. No worries. So we don't have this strict condition. We will have two lectures this week before Ramadan, Tuesday and Thursday, and then we will continue after Ramadan. The schedule is fixed, 6 p.m. Egypt time. Each lecture will have 2 hours. Then some would say ethics, some etiquette about the lecture itself. Whenever someone wants to speak in the mic, please don't just open the mic and speak, because if someone also is speaking at this time, this will be a mess. So whenever you have some question, some comment, or whatever, usually put it in the chat. And if it's too long, or you told me something, but I'm not fully getting it, and you need to speak in the mic, just use the raise hand reaction. In the Zoom control panel, you can find the react symbol. So one of those reactions is raise hand. You can try it yourself right now, just to see it. So when you raise hand, I see it. So if I'm in the middle of something, you have to wait until I'm done. If not, I will say X, please go ahead, go on mute and tell me what is the problem or blah, blah, blah. So the main communication point will be the chat, unless the chat is unswipable. And this will happen in a lot of situations. For instance, I need to write a very lengthy paragraph to tell you what I feel, what I want. So this is time consuming. So please just use the raise hand reaction. I will see it and I will give you the mic whenever it's appropriate. based on the context of the lecture. I'm delivering something, I'm explaining something, or I'm idle. It depends. So this is a quick intro about the course, some rules, introduction about myself, my background. Any questions, comments, concerns before we share screen and start explaining the slides? Awesome. I'll share my screen. Also, please make sure that your mics are muted and also your cameras are off for your own privacy. And your mics muted to avoid any noise, background noise happening at the end of any one of us. Here we go. Okay, I always like to start with the title, Lean Six Sigma Yellow Belt. What does it mean, all of that? Let's take it word by word to understand the main idea about our course. The word lean, by dictionary, it means meat without fat. Or when I say that's a lean person, it means that this person has a lean muscles and a pretty handsome body with a lot of muscles. So it always refers to something without bad issue or without like muscles, without fats. It means something clean, something ready to eat, something ready to be used by dictionary. In quality, lean simply, exactly like the analogy of muscles without fat, we need the process without waste, like waste of time, like waste of motion. We will discuss this in details later. So when I say lean process, it means it's streamlined without any types of waste. And there is a specific types of waste that we'll be discussing later on. Lean, invented by Japanese. So it began to formalize by 1955 in Japan through Toyota via something called Toyota Production System. By the way, it's pronounced Toyota, not Toyota or Toyota, named after Sakichi Toyoda, the founder of Toyota. So this mean principles, TPS, Toyota Production System, was the foundation of Lean, 1955, and later on it evolved a lot through 60s and 70s until it reached what we will be teaching you till now. So Lean has no statistics at all. Lean is simply logic, intuitive, simple tools based on brainstorming, which is a little bit different to what is happening in Six Sigma. Six Sigma, on the other hand, focuses on variation. So what do we mean by variation? I believe you are healthcare specialists. Correct me if I'm wrong. If anyone here not from healthcare background, please drop me yes in the chat, just to understand your backgrounds. Usually, usually our candidates here are coming from healthcare, but it is not strict condition. Fahmi, from what background you are coming? Chemical engineering or chemical manufacturing? Are you working in manufacturing plant or give me more details, please. Manufacturing, perfect. In what sector of manufacturing? food and beverage or general production or whatever. Sterilization. Batteries. Okay. Sterilization of products. Okay. So medical devices sterilization. Thank you so much. Perfect. So everything I would say, I will give one example in healthcare, one example for manufacturing, for both of you. Surgical innocence. Okay. So let's say that we are in a hospital and we are measuring the waiting time, the outpatient. So we have some patients waiting to enter to the physician. Will all those patients have the same exact waiting time? Can I say that each patient will wait exactly 30 minutes before he or she sees the physician? Is that correct? No. On the other hand, this is impossible. So this is variation, simply. Not all the patients will have the same waiting time. And even if when they enter to see the physician, they will not stay with the physician the same exact time. Also, this is variation. On the other hand, in manufacturing, say that I'm saying that the cycle time to produce unit X from product Y is 20 minutes. Does it mean that each and every unit produced and will be processed or produced in exact 20 minutes? No more, no less? Again, the answer is no. There would be a variation. And sometimes the manufacturer will highlight this variation using a plus and minus notation, which is originally coming from statistics, as we will see during the course. So this is variation. Even if you pick something that you are doing in daily life, do any one of you arrive at work exactly on the same time each day without any variation? So I reach work 9 a.m. sharp, and I will always will. No any even 1 minute late or 1 minute early. Does it make sense? Again, no, doesn't make any sense. All of these examples, what we meant by variation. Whatever the example, whatever the industry, whatever the KPI, whatever manufacturing or service, it's always good thing to reduce variation. Reduce variation. And don't mix reduce variation with the objective of KPI because this is a major pitfall. Someone of you will say, no, I need to increase, for instance, the customer loyalty or the customer satisfaction. This is completely different thing. Whether the KPI should be minimized or maximized is completely different from what we are saying. Whatever you want to do with your KPI, whether to increase it or decrease it, in both cases, you have to reduce variation. Reduce variation doesn't mean that you are decreasing the KPI. No. If you have some customers and you are measuring their customer satisfaction or their customer loyalty, for sure we want all of these numbers to be high. But even amongst these high numbers, do you have high variation or low variation? If you have a high variation, that's a problem. So in business, we want always to reduce variation. And this is the main objective of Six Sigma. I don't like to have a patient who is waiting for 5 minutes and the others waiting for 1 hour. This is not healthy for the process. And I don't want to produce some product in 20 minutes plus or minus 5 minutes. It means cycle time between 15 to 25, which is very high. I need something to be 20 plus or minus 1, which will give me much narrower interval from 90 to 21. Mm. So here I'm decreasing variation. I don't want a customer who have a loyalty or satisfaction index of 5 and the others have 1s. Both are satisfied, but there is much variation between them. So both are satisfied. But why this one rate me as 1 and why this one give me 5? If this is repeated, it means we have high variation in your data. So in business, and of course, in Lean Six Sigma, or specifically Six Sigma, we want to reduce variation because this is unhealthy. It means whatever I do in terms of products, whatever I'm dealing with, patients, customers, whatever, they are not getting the service with the same level. There is a huge variation between what they are getting, which is unhealthy. And for sure, this will force those who received bad service to complain and rate you lower, and so on. So this is initially what is meant by variation. And the main objective of Six Sigma is to reduce this variation. I will stop here and ask if you have any questions. Didn't finish for sure, but let's see whether so far so good or you have any questions. Very good. So good so far. Unlike Lean, Six Sigma is American. USA. It appeared in 1986 in Motorola. And again, it's pronounced Motorola, not Motorola. There's no double L. It's only single L. So one Japanese, one American, one in 50s, one in 80s. One is concerned with waste and the other is concerned with variation. This is the main differences between Lean and Six Sigma. And this is one of the most frequent questions we receive in those courses. Give me difference between Lean and Six Sigma. I don't understand. So I hope now you understand. So let's clear all of those and pick again Six Sigma. So as a whole, we understand now the Six Sigma is dealing with variation, blah, blah, blah. But why it's so called Six Sigma? Why specifically six? Why not five or seven or 10 or 100? Why? And what does it mean, Sigma? Let's pick the easiest one. Sigma, which is this symbol, is a Greek letter. Mathematics and statistics is filled with Greek letters. So sigma uppercase, because we have sigma lowercase. So the Greek alphabet has uppercase and lowercase symbols exactly like English. Uppercase A, lowercase a. The same applies in the Greek alphabet. So this is sigma uppercase, which denotes standard deviation. In Arabic على الانحراف المعياري. While sigma lowercase is simply summation, sum, المجموع. If you are using Excel, in the home file of Excel, you can find this symbol, which means simply sum, المجموع. 1 plus 2 plus 3, summation. So sigma, we meant here the uppercase sigma, and stands for standard deviation. We will know in a minute what does it mean standard deviation أو الانحراف المعياري in Arabic. So sigma means the uppercase Greek letter sigma, and it means standard deviation. So what's standard deviation? I think intuitively and unsurprisingly, standard deviation in statistics is a measure of variation. And I think this is very intuitive. because I just said that Six Sigma methodology is interested in reducing variation. So in order to reduce something, you have to measure it first. Einstein quoted saying, what you can't measure, you can't improve, simply. So standard deviation is a measure of variation. It's a statistical uh, measure that we use it on a column of data to understand how this observations are clustered around the mean, exactly, variation from the mean, exactly. So let's understand how standard deviation mathematically derived. Let's say we have some data here, sample, we'll call it S. So we have some sample, some observations. The standard deviation for a point simply means distance between this point and the mean. So let's open a new one. In statistics, when we want to very quickly draw distribution or a process or a variable, we draw it like this. By the way, this is a normal distribution, and we will speak about it in later lessons. And this is the mean or the average. Can anyone define the average? How we calculate the average? If someone knows, of course. Sum over count. المجموع على العدد. Sum over count. العكس يا فهمي، المجموع على العدد. For instance, if I have here 1, 2, 3, and I need to calculate some of the observation beside it. But then, anyways, look with me. Sum over count. Yes, I believe sum, SUM, divided by the number. Yes, that's correct. So simply I will add 1 plus 2 plus 3 equals 6. How many numbers I have here? I have 3. 3 divided by 6 divided by 3 equals 2. 2. And by the way, the mean is the average because I have met with some people previously who thought that average is different from mean. Average is a more statistical formula, and formally it's the arithmetic mean, المتوسط الحسابي. إيه ده، هو في متوسطات تانية؟ Yes. In mathematics and statistics we have harmonic mean, we have geometric mean, much more. So average is the arithmetic mean, المتوسط الحسابي, which is calculated using this formula. And this is the one we are interested in. We're not interested in the other types of means, but there is many, more than 7 different types of means, not only the arithmetic mean. Okay, so now we understand how we can calculate the mean. So when you have some data in a column, and if you draw the column like this, and this is your mean, simply there is or there are an observation above the mean and the other observations below the mean. This is very intuitive. Otherwise ما كناش سميناها المتوسط. يعني ايه متوسط؟ يعني if I have some observations like this, it will be here. There are some observations greater than and there are some observations lower than the average. من هنا جت التسمية المتوسط لأنه بيتوسط الشيء. So everything here on the right is greater than the mean. Everything here on the left is lower than the mean. Let's go back to the standard deviation. How do you define standard deviation for a point? Let's pick this point. The distance between this point and the mean. So it will be this horizontal distance. Let's pick another one. This point, for instance, again, definitions applies, distance between this point and the mean, and so on. And as you can see, let me ask you a question. The standard deviation will be always positive, always negative, or mix. It could be positive and negative. What do you think? It will be a mix of them, positive and negative, because if we take this point is greater than the mean or lower than the mean. This one, greater. So when I say x minus x bar, and x bar is a symbol for the mean in statistics, and given x is greater than x bar, it will give me a positive number. What about this point? This point is greater or lower than the mean? Lower. So when you take a point, say minus x bar, and this is lower than the mean, you get a negative number. So standard deviation could be positive, could be negative. It depends. The observation is greater than the mean or lower than the mean. And by the way, from this notation came the plus and minus most manufacturers put on their devices. لما تروحوا كده تشتروا ميزان حساس للبيت وتقلبوه كده او تفتحوا المانوال بتاعه هتلاقي مكتوب بلس اند ماينس او بوينت معرفش ايه. لو انا عندي جهاز تصنيع بيعمل واتس ايفر ايه اللي ممكن نحلم بيه، ففتحت المانيوال بتاعه وبصيت عليه من الجنب هلاقي مكتوب عليه بلس وماينس. This all comes from standard deviation from statistics, by the way. Good. But are we interested in calculating the standard deviation of each point in our data, or we are interested in the overall standard deviation؟ أنا مش هعدي عليهم point by point. أنا كده هيجي لي أنا point، هيجي لي نقطة. No. I'm interested in the overall standard deviation of the process. Hence, we want to tweak the definition a little bit. So the standard deviation of a point is simply distance between this point and the mean. What about the standard deviation for a process? Average distances between all the data points and the mean. Again, the average distances between all the data points and the mean. Let's apply this definition on the first slide. So now we have data and we can calculate the mean. And then let's apply the definition. The average distances between all the data points and the mean. Average distances means I should grab the distances first. I will call it D, D for distance. So simply, I will take each observation and subtract it from the mean to give me some numbers here. One by one. Again, those distances are solely positive or solely negative or mix. What do you think? It will be mixed because, as we said previously a few minutes ago, this is an average. It means that somewhere here, observations greater than average minus average give you positive. Observations lower than the average minus the average mathematically will give you negatives. So we have here a mix of positives and negatives. Let's continue with the definition. The average distances. Okay, you got the distances. Now you have to average them. Question for you. Mathematically speaking, can I average a mix of positive and negative numbers? Is it mathematically valid and why? Okay, mathematically it's invalid. No, because they will cancel each other and may give you zero. If you have here minus 2 and plus 2, for instance, minus 2 plus 2 equals 0. Hmm? So this may give you 0 or give you a very misleading number. You cannot, mathematically speaking, average hmm, a mix of positives and negatives. So what can we do to avoid this? We will square to avoid the negative sign. We'll take each distance of those and square it to have distance square. So now what is positive will remain positive, and what is negative will become positive as well. So now we avoided the problem of the negative sign. Now you can average these square distances, but this will not give you standard deviation. Will give you variance, sigma square or variance. Because the definition of variance is the squared average distances between, or the average square distances between all the data points and the mean. And unlike a lot of people think, the original parameter in statistics is variance, not standard deviation. Some people think that originally we have a standard deviation, then we may square it to get a variance. On the contrary, is the correct thing here because originally you got the variance. If you want to get the standard deviation, simply you have to take the square root, الجذر التربيعي. Then you have standard deviation, what we are looking for. Mathematically speaking, you squared for a reason, which is to avoid the negative sign. You achieved what you want, perfect. Reverse the operation. What is the reverse operation of squaring? It's taking the square root, which we are doing here, to convert the variance back into standard deviation. And this is how standard deviation, or sigma, mathematically derived. And in practice, you don't have to do it manually. But as a Lean Six Sigma person, you have to understand it because you have been asked this question. What does it mean, Six Sigma? And what does it mean, Sigma? Then you will say it's a measure of variation. Perfect. Then they will ask you, what does it mean, variation? We'll give an example. Okay, give me an example to understand more how you are calculating standard deviation. So if you said just Excel will calculate it or Minitab will calculate it, this is not a good sign for you. It means بالمصري كده البلدي حافظ مش فاهم. يعني اللي علمني قال لي استخدم كذا خلاص ما قاليش احسبها ازاي. وكجزء من indirect resistance اللي بنشوفها كتير في السكس سيجما this is not good for you. بعض الناس هيسألوا عشان عايزين يعرفوا فعلا، وبعض الناس بيسألوا لأنهم مش عاجبهم الكلام، فيفضل يسألك 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 لحد ما تقول له لا أنا ما أعرفش، يقول لك أنت جايب لي حد عايز يأضبط حاجة هو نفسه مش عارفها. How come؟ فده يبقاش سؤال حقيقي، يبقى فخ. So I'm very interested to whatever built people with me, yellow, green, black, they must be strong in statistics. This is in your favor. because whatever the reason is, really knowing or just simply indirect resistance, it's you should have answers. Whatever question been directed to you, you should answer, should have answers. So in practice, you don't have to do all of this manually. As I said, any statistical software or even Excel, which is spreadsheet software, can calculate it for you. But there's a huge difference between I can calculate it and I don't understand what's happening under the hood, and someone, other one, who can calculate it and also he or she understands what is happening under the hood. And this will differentiate a good Lean Six Sigma professional from a bad Six Sigma professional. So this is everything I need you to understand about standard deviation. It could be positive, it could be negative, and it makes a lot of sense when you put it plus the average, as we said. So I can ask you, on average, what is the lead time? Say you are working in Amazon. What is the lead time for a product to reach a customer? Lead time, it means from the point of time you are making an order until you receive the order. So you ordered the mobile phone from Amazon. From the date of ordering until the receiving date, this is called the lead time. Then one of Amazon's company will say, oh, the lead time is on average 10 days. On average, 10 days. Perfect. It means that every and each order will take exactly 10 days? No, because we have something called variation. Here comes into the play the standard deviation. When you say 10 plus or minus 1 day, this make a lot of sense. It means the lead time may varies by plus or minus 1 day. So we have a range, we have an interval from 9 to 11 days. So standard deviation or any measure of variation in general alone is not completely interpretable unless you combine it with the mean or the average. Here it makes more sense to understand it. And as I said, plus and minus coming from standard deviation statistics, you can find it anywhere in production, in healthcare, in call centers, in banking, whenever you have a device, whenever you have something that is producing something, measuring something, even the home weight scale, ميزان البيت. كلنا عندنا ميزان في الحمام كده نحب نتوزن، نطلع نقف عليه، اقلب كده الميزان ده او بص عليه او بصي عليه من فوق هتلاقي مكتوب عليه بلس وماينس رقم كيلو ونص كيلو. It means الشخص اللي اخترعه بيقول لك خلي بالك it may deviate by. انت نفسك لو وقفت عليه دلوقتي حالا ممكن يديك 80، تنزل وتطلع يديك 80 و2 من 10 عادي جدا. م? هو ده الفاريشن. فاريشن everywhere around us. مفيش حاجه اسمها مفيش فاريشن، مفيش حاجه اسمها زيرو فاريشن. كل الفيلم ده، كل الموال ده just to illustrate what is sigma. م? And there is a strong relationship as you can see. Six Sigma wants to reduce variation, and sigma is a measure of variation. I'll stop here. If you have any questions, please let me know. This is something I will say. Any questions? It means any questions in what I have said. Y6 will speak about this. But when I ask you any questions, I mean any questions in what already I said. Y6, we will explain Y6. But this is something we need to go through yet. Okay, Y6 means any questions in what I have said. So, in order to complete what we're saying, we have to open a new one, Y6. We will understand in a while that Six Sigma performance implies something called 3.4 DPMO, which we will be studying in details. But what I want to highlight is that there is an incorrect explanation that is widely spread in the quality societies all over the world, and it comes from incompetent instructors who didn't study statistics on the academic level. So they will tell you that it's called 6 عشان 3 و3. عشان أعمل لك كده 3 ستاندرد ديفيجن يمين و3 ستاندرد ديفيجن شمال، وده غلط تماما. This is incorrect, and this is coming from someone who didn't study statistics at all. He knows Six Sigma, but don't know statistics. Because 3 and 3 3 و3 اللي بنسمعها كتير دي ليها علاقة بالكنترول تشارت SPC، قاعدة إحصائية اسمها the empirical rule invented by God himself كارل فريدريش جاوس، وليس لها أي علاقة بالسكس سيجما من قريب أو من بعيد. فأول حاجة أحب أوضحها قصة إن السكس سيجما اتسمت 6 سيجما عشان 3 يمين و3 شمال، ده غلط. هندرس الامبيريكال رول in details later on. So why 6? This will force me to speak about things I wasn't planning to say at the beginning, but anyways, it will be illustrated. So let's go through it. First of all, we need to understand that when a standard deviation increases, it means variation increases. There is a direct proportional relationship between them. And also there is a huge difference between sigma and sigma level. When I say sigma level, this is something different. Sigma is a statistical measure of variation, as I said, have been in statistics since 1700 وشوية. But sigma level is related to the Six Sigma methodology. It's a scale from 0 to 6 and could be negative, by the way. Sigma level could be negative. But let's, for a start, let's say from 0 to 6. 0, 1, 2, 3, 4, 5, 6. As the sigma level increases, approaching 6, the variation decreases. So there is an inverse relationship between sigma level and variation. This is very crucial to understand. Please don't mix them. It's completely different things. Sigma alone, it means a standard deviation, and it's directly proportional to variation. Increase, increase, decrease, decrease. While sigma level or sigma scale, those are discrete numbers, not statistical numbers. Sigma is statistical parameter, invented by Bill Smith, an engineer from Motorola who invented Six Sigma. So it's something not non-statistical. 6 is the best. It means very low variation, while 0 is the worst with very high variation. Why Bill Smith, while developing this scale, stopped at 6? ليه ما وقفش عند 7 عند 8 عند 9 عند 5 عند 4 اشمعنى 6 يعني؟ This is completely rational for him because, as I said, sigma level or 6 sigma level, which is the highest from his point of view, will give me something called 3.4 DPMO. What does it mean, DPMO? Defect per million opportunity. And again, there is a very incorrect, widely spread explanation for DPMO, which mixing DPMO with PPM. So when you say or ask someone, what does it mean 3.4 DPMO? Will say you from 1 million product, I have 3.4 defects. Or from 1 million prescription dispensed, we have 3.4 defects. This is completely wrong. This is PPM, part per million. completely another parameter. DPMO or defect per million opportunity. Opportunity it means probability in statistics. من مليون احتمال للخطأ بخطأ 3.4 من 10 which is after rounding 3. Amongst 1 million probability for making a mistake I'm mistaken in 3. حد يقول لي حلو بس ما فهمناش برضو ليه 6. تعالوا نترجم الكلام ده الأول لمثال عملي عشان تفهموا ليه هو توقف عند 6. Why he stopped at 6? Because simply in 80s he find that it's impossible for someone, some organization to reach even 6, so he simply stopped at 6. It could be 7. For instance, NASA at 2010 declared that they are operating at 10 sigma level. So there is no limits. Sigma level could be negative, could be zero, and could be any number greater than one, by the way. Okay. So again, why he stopped at 6? Let's have a very simple mathematical example to understand this. And we take two examples, one from healthcare, one from manufacturing. Healthcare people. What are the opportunities for a physician to make a mistake while he is prescribing or writing a prescription؟ ايه الاخطاء اللي ممكن يقع فيها الطبيب؟ دي احتمالات الخطأ. دي بي ام او ها. ايه الاحتمالات اللي ممكن يقع فيها وهو بيكتب روشته؟ محدش يفضل يوهم لي ادوني رقم. طبعا يعني ممكن يكتب اسم الدواء غلط، اسم المادة الفعالة غلط، التركيز غلط، الفورم غلط، الاستخدام غلط، وانا عارف ان هم كتير عشان ما تعبكوش. كام يعني؟ ادوني رقم كده، فكروا كده وادوني رقم. ايه هو عدد الاحتمالات الخطأ اللي ممكن يغلط فيها اي طبيب في الدنيا وهو بيكتب روشت؟ على الجانب الاخر الناس بتوع المانيفاكتشرنج manufacturing people think about the same. While you are producing a specific product ولا بلاش برودكت، خلينا نتكلم على المينتننس. while you are planning for a corrective maintenance, what are the number of the total probability of defects that may lead to equipment will be down؟ في معدة بقت down unscheduled. طبعا مش بتكلم على الscheduled maintenance، ده معروف. unscheduled ايه هي الاحتمالات اللي ممكن تؤدي عددها الى ان المعدة دي تبقى down؟ No, I don't need a percentage. I need a number. Give me, say, 10 probabilities, opportunities, 11, 12, 30, 40. I don't need a percentage. I need a count, number. How many opportunities for a defect? And the same applies to the maintenance example I just mentioned to the manufacturing guys. What are the number of opportunities or probabilities through which an equipment would be down, unscheduled? 5 10 من عندي 20. يلا. مم. الناس بتوع المانيفاكتشرنج. يا ريت نخلي المايكس بتاعتنا مقفولة. اديني رقم. انا عارف ان هو بيزد على الاس او بيز طبعا، لكن اديني رقم من خبرتك كده، اديني رقم. احنا مش عايزين نحول الاكزامبل لحاجة فيري تكنيكال في تخصصاتكم، أنا عايز رقم. هم مثلا قالوا لي 5 10 من عندي انا خليتها 20. حد يقول لي انت هتزودها ليه؟ طب اقول له خلاص مش هزودها، ناخد رقم متوسط كده، ناخد 10 ما يجراش حاجة. طيب ليتس سي ان انتوا قلتوا 10 برضه. العامل ما بيلتزمش بالاس او بيز، مهندس ما بيلتزمش بالاس او بيز، ما تعمل لهاش كوركتيف مينتنانس قريب، ان سكادولد مينتنانس نوت كوميونيكيتد. ده اللي انا اقصده، يعني كنت عايز حد يعد ويقول هو سي 10. حلو. دلوقتي انت بتقول لي ان انا عشان آه، يكون عندي 6 سيجما ليفل، فانا محتاج من مليون احتمال للخطأ اغلط 3، 3 4 من 10 افتر راوندنج 3. طيب حاليا في المثال اللي احنا اخذناه ده، احنا ما عندناش 1 مليون، احنا عندنا 10 opportunity for a mistake. يعني المفروض تعمل كام ديفكت؟ solve for x، شيل الصفر ده مع الصفر ده، يعني 3 على 100,000، يعني 0.00003. في الاكزامبل اللي احنا بنتكلم فيه ده، لو عندي هنا 10 opportunities for making a defect عشان اوصل بالبروسيس دي for a 6 sigma level، it means I should do 0.00003، يعني زيرو ديفكت اصلا. اعتقد دلوقتي كلنا فهمنا ليه هو وقف عند 6، لان شاف ان الرقم ده رقم صعب ان حد يوصل له. وده على مستوى الشركات الطبيعيه مانيفاكتشرنج او سيرفيس، صحيح ماليش دعوه بناسا، ناسا دي ليها بادجت greater than some countries budget، ميزانيتها اكبر من ميزانيه دول. ماليش دعوه بناسا، ناسا دي على جنب. لكن بس حبيت اديكم مثال ان السيجما ليفل ممكن تبقى زيرو، ممكن تبقى نيجاتيف، ممكن تعدي السته. هو ما وقفش عند سته، mathematically it's a relationship، it's a function، it could be anything. That's why simply Bell's mass stopped at 6 because whatever the number of your probabilities، خلينا نخلي الرقم ده مثلا 100، برضه هتلاقوه 0.0 حاجه، صعب قوي يزيد عن 100. ف whatever the number of opportunities of number of probabilities for making a defect 10 20 30 40 50 100 150 حتى 200، نيجي نعمل الحسبه دي كده we'll find always that in order to operate at 6 sigma level you have to make a zero defect which inapplicable till now. Simply that's why Bill Smith stopped at 6. This was his rationale. And his rationale holds still point. لحد دلوقتي ما وصلناش لمرحله ان في اورجانيزيشن كامله بتوبريت ات سيجما ليفل. في اورجانيزيشن عندها بعض البروسيسز بتوصل للسيجما ليفل، ل 6 سيجما ليفل، لكن the whole organization no، لسه ما وصلناش للمرحله. طب لو وصلنا عادي، هنعدل السكيل نخليه 7 8 9 10. It's a mathematical function math. وهنا نيجي لنقطه مهمه جدا. A lot of people, even those who studied, they think, and this is completely incorrect, that the main objective of Six Sigma methodology is to reach Six Sigma, which is completely wrong. ده اللي بيخلي بعض الناس تقعد تقول لك لا دي ما ينفعش غير في الافيشن، في الطيران، لا دي ما ينفعش غير مانيفاكتشر. correct. Who told you that the objective of Six Sigma is to reach Six Sigma? The objective of Six Sigma is to reduce variation, whatever your original sigma level and whatever your target sigma level. We don't care. As long as you are reducing variation, you are solving problems, you are improving processes. And this is a golden rule. Again, the main objective of Six Sigma is not to reach Six Sigma level. بيل سميث ما حطش الستة عشان الناس توصل لها اطلاقا. It depends. في ناس عندهم السيجما ليفل بالنيجاتيف، جاست ان هو وصل لزيرو او عدى الزيرو، ده بيعمل امبروفمنت رهيب جدا. KPIs wise. Second thing, management, middle management, top management are not interested at what Six Sigma level is. For them, it's a bullshit. I don't care. I have a business KPI, huh? And I have a problem that the business KPI is not achieving its targets. And I ask you to open a Six Sigma project, identify the root cause, solve it, and hence it's become more and more close or even achieving its target. This is what sorry companies are interested in. فالناس بتضيع عمرها حرفيا في السيكس سيجما على السيجما ليفل ومش السيجما ليفل، وراحت وجت في حين ان رياليتي على ارض الواقع الشغل، البيزنس، المانجمنت، كل ده بالنسبه له بولشيت ولا يهمه. المره الثانيه، بيزنس يهمه شيء واحد. عندنا بيزنس كي بي اي، واقولها بالعربي. الكي بي اي دي ليها تارجت؟ في كي بي اي ملهاش تارجت؟ ما فيش، ما كانتش اتعملت. الكي بي اي دي مش جايبه التارجت بتاعها. الويتنج تايم المفروض يكون نص ساعه، حاليا هو ساعه. الليد تايم ده المفروض يكون 40 دقيقه، حاليا هو مع كسر ال 40 دقيقه. م? المفروض التارجت برودكشن ريت بتاعنا في الشهر يكون 4 مليار حته، حاليا هو 3 مليار بس، مش عارفين ليه. كي بي اي مش جايبه التارجت بتاعها. هو ده السكس سيجما، وهو ده الاوبجيكتيف من السكس سيجما، ان احنا نقدر نوصل للروت كاز. معرفه الروت كاز لوحدها بتقلل الفاريشن بطريقه غير مباشره، بحيث ان الكي بي اي دي تقرب للتارجت بتاعي او تحقق. انت وحظك، ممكن توصل للتارجت رايت فيرست تايم، وممكن تقرب. من هنا جت تسميه البيرفورمانس امبروفمنت او كونتينوس امبروفمنت. اللين 6 سيجما في الكواليتي بتندرج تحت الكونتينوس امبروفمنت تولز. الكواليتي مش حاجه واحده. في الكواليتي اوف ديزاين، ده بالصلاه على النبي كده مش موجود عندنا، موسى نبي وعيسى نبي ومحمد نبي، كل نبي يصلي عليه. وفي الكواليتي اوف ستاندردز او كونفورمانس، اللي هي الايزو والجي سي اي والجهار والمعايير المصريه، وايزو بقى بمختلف انواعه. وفي الكواليتي اوف امبروفمنت، دي اللي بيجي تحتيها بدايه تاريخيا كده البيديكا والفوكاس بيديكا واللين، وبعد كده السكسي توز تعمل امبروفمنت. فمش مطلوب ابدا ان انا اوصلك للتارجت رايت فيرست تايم. It may happen which is good but may not. لكن at least there is an improvement. حصل ايه؟ حصل تحسن في البروسيس. فطول ما انا متخيل، وهقولها بالعربي، ان الاوبجيكتيف من السكس سيجما ميثودولوجي ان انا اخد بروسيس او اورجانيزيشن واوصلها ل 3.4 من 10 دي بي ام او، ده غلط تماما اطلاقا. It's all about improvement. بزنس كي بي اي وتارجت، نوصلك للتارجت او نقربك من التارجت، وبقولها بالعربي. ذاتس ات. في ناس بتفني حياتها في السيكس سيجما وتحسب وتعمل في النهايه الشركات المانجمنت not interested of what does it mean sigma level, how you measure sigma level. يعني ايه سيجما ليفل؟ ظهرت امتى؟ بتقيسها ازاي؟ بولشيت بالنسبه لهم. They are much interested in just key business KPIs. تقدر تحل لي مشكلة تحسن لي الكي بي اي؟ Can you make an improvement that make me close to target؟ البريكس ليها مواعيد ثابتة. بعد أول ساعة بناخد ربع ساعة، بعد كده بنكمل whatever بدأنا الساعة كام. لو حد عايز يعمل أي حاجة قبل مواعيد البريكس الرسمية، ممكن محاضرة ريكوردد، ممكن يروح يعمل وات ايفر هو عايز يعمله، يرجع يكمل معانا تاني. لكن البريكس هي دي مواعيد. بعد ساعة باخد ربع ساعة، وبعد كده بكمل. فالبريك المفروض ميعاده كمان 3 دقايق بالظبط. لأن لو فتحناها لكل حد عايز بريك عشان يعمل حاجة أو عاوز بريك لحاجة معينة، طبعا هتبقى مس. فنظام البريك كالآتي: بدأنا في وقت معين اللي هو يوجوالي 6 بتوقيت مصر، 1 hour then 15 minutes break then we continue. Today we started 6:10 ف 7:10 we'll go to a break. نرجع للمهم. فهمنا يعني ايه 6 sigma and why it's called 6 sigma و from where we got the number 6. Or in other words, any questions in what I have said. دايما any questions I mean في اللي انا قلته، مش لسه هقول. يعني مثلا اقول في اسئله، فحد يقول لي كنترول فيز بتعمل ايه، ما شرحناش لسه حاجه في الكنترول فيز. ف whenever I say any questions I mean any questions in what already I illustrated or explained, not something futuristic, just to set some rules during the course. If we decrease variation, then we reach high performance level. Correct. 100%. The variation is high. That's why you are not getting your target for a reason. Identifying this reason in the analyze phase using Six Sigma and correct it will decrease the variation and hence you can reach your targets. Very good. So no, I can't read this question. On build Shap Six Sigma at corner. I think there is maybe due to the keyboard or something. I can't read it. So now we are finished with this part. After the break, we'll discuss what is yellow belt, what is built, and what is yellow. Okay, take your time, Mariam, in rephrasing the question because maybe due to the keyboard or something, it's unreadable. On build Shap Six Sigma code, I can't understand it. Take your time during the break. Then we'll discuss this after the break, inshallah. Now it's 7:10. We'll take a break for 15 minutes and back in 7:25. Enjoy your break. See you then. Bye. Back. Hopefully you enjoyed your break. So let's continue. The title. We are done with Lean Six Sigma. So what is yellow? What is built? So the Lean Six Sigma training is following the pattern of dividing the knowledge into tiers. It is not all or none, whether you are MBA holder or not, you are TQM holder or not. So they follow this in the early 90s. So we have different levels of learning. So the yellow belt is the first step on the Six Sigma ladder. Usually it's 30 hours. So belt simply means a tier or a specific level. Think of it as of Bachelor of Science, Master of Science, PhD, postdoctoral fellow, for instance. So it start with yellow, the bachelor, this is the basics. Then green belt, which is masters. Then black belt, which is similar to PhD, for instance, and then the Master Black Belt MBB, which is something like postdoctoral fellow. So it just tiers. To set expectations, our course is yellow belt, so think of it as an introduction to Lean Six Sigma. This is an introductory course. So you will not know and learn everything in Lean and everything for Six Sigma. On the contrary, just an introduction. I'll give you a very good glimpse of what is Lean, what is Six Sigma, and some tools for sure. But if you are interested, if you like it, then you have to go a step further, green or black. And this is something you have to decide by the end of the course. You cannot decide by the start. So that's just to set expectations because during the course, I will hear some questions about we heard about X, we heard about Y, why we didn't do it. This is just a yellow belt. Yellow belt is the basics of Lean and Six Sigma, and the first step on the other. So intuitively, you will not learn everything in Lean Six Sigma. You still have green and black uh, to go for if and only if you like the course and you decided that Lean Six Sigma is something you would have to be interested in. So build simply means different tiers, different amount of knowledge, and yellow, green, black, master black belt are different belts or different amount of knowledge, different levels of knowledge, and each one pick whatever it suits him or her. Again, this is something you would be able to understand once you are done with the course. This is my question. Where is Six Sigma on this diagram? No Six Sigma here. This is just the normal distribution and empirical rule applied on it. And that's why you can see the letter or the word sigma. Sigma, it means division. There is no Six Sigma here, or there is no Y Six Sigma is applied here. Just this is the normal distribution, or the bell-shaped distribution, or the Gaussian distribution, with plus 6 standard deviations to the right and plus 6 standard deviations to the left. So this is will be more and more clear once we study the empirical rule together. So here there is no Six Sigma. This is a normal distribution on which we have the empirical rule. What is a normal distribution? What is the empirical rule? That's something we'll be studying very soon. I hope that I have answered your question. But the issue of Six Sigma, named Six Sigma because three standard deviations to the right and the three standard deviations to the left is completely wrong. This is what I can tell you at the moment. But the complement of the answer of your question will be answered later once we study the empirical rule. Okay? Okay. Now we are done with the title. Let's go deeply into more and more about Lean Six Sigma. Start off with Six Sigma. So how we are doing Six Sigma projects in reality? Six Sigma has a very clear and distinct methodology called DMake. And it's pronounced DMake because some people pronounce it DMake or DMake. Both are incorrect. It's called DMake. DMake. D for define, M for measure, A for analyze, I for improve, C for control. And this will be our course. Our course is to go through each one of those levels or phases or stages in the context of your build for sure, and tell you what we are defining, what we are measuring, what we are analyzing, what we are improving, and what we are would be controlling. So simply each phase of this is our course. We will pick each one of those phases and dig deeper to understand what does it mean. And this is the beginning. So for sure you will be very curious. You are defining what, measuring what, analyzing. So in define phase, we are defining the business problem. And as I said, the business problem for us is very clear. I have a business KPI metric, and it is not achieving its target. This is the main business issue for us. From here, we start saying, okay, Six Sigma project will be opened here. Then M, measuring the process, which is how bad is the pain. Now you know the pain, but how bad is the pain? Maybe you are not achieving the target, but you are close. Maybe you are very away from your target. It depends. For instance, specific manufacturing plant have a production daily rate of 1 million units. Now they are achieving 900,000 units. They have a deficit of 100,000. Another manufacturing plant have the same target, but they are producing 600,000. Both are not achieving, but how bad is the pain? The pain is very bad for the next second scenario, but not so bad in the first scenario. As Einstein quoted saying, what you can't measure, you can't improve. I need to understand from where I stand, the current situation, and my target, and then I can understand or I can go through the Six Sigma project. So measuring simply means for us in Six Sigma to measure the current Sigma level and to understand the current performance of the process and its relation to the target. Your target is maximum 30 minutes for a specific time for any lab test or a specific lab test. Now the time is 40 minutes, so you are 10 minutes away from your target, and so on. E, simply analyzing what? It answers a very basic question: what is the root cause of the pain? The pain, which is the variation, as I said before the break, doesn't happen synonymously or without reason. No, there is a reason. When I have high variation in my process, there is a reason. There is a root cause. Once you identify this root cause and correct it, the variation decreased and the process achieves a target or come closer to its target. Improve phase إذا عرف السبب بطل العجب. Now you have the root cause. You understand the root cause. You know the root cause. So simply which solution will eliminate this pain? I understand that the root cause right now is low number of engineers or low numbers of nurses or unavailability of X, unavailability of Y. So simply you can work on a solution for this. Once you have a solution or a correction to your main root cause, then you have to control. Because simply the objective of control phase is to guarantee the sustainability of our solution. I don't want a solution that lasts for a couple of months or for a quarter or semester and then the problem creep back again. No, I need something sustainable, sustainability. So phase is all about sustainability. How can we sustain the gains? How to make sure that the main problem will not creeping back again. So this is in more details. What is the make? Define, measure, analyze, improve, and control. Any questions in this slide that they make? Okay, good. Now let's talk a little bit history about Six Sigma. So Six Sigma, as I said in my introduction, was born when Motorola launched its Six Sigma quality program 1987 or 1986. Both are correct. Then Six Sigma transferred to another companies such as but not limited to General Electric, Allied Signal, Honeywell, much others. As we said, a lot of what I have explained on a whiteboard or on first slide is already documented in the materials, but we had to talk about beforehand to make things clearer. So a lot of what you are going to see in the next upcoming slides, we already explained during the first part of the lecture. Sigma, as we said, is a Greek letter used by statisticians to denote the standard deviation. And standard deviation simply is a measure of variation. On the other hand, sigma value or sigma level or sigma scale or sigma metrics, they are all synonyms. It's a metric to indicate the performance of a process. And it ranges from 0 to 6 practically. Theoretically, it could be negative or could be greater than 6. It's a mathematical function, unbounded, no limits. Some terminology that I believe you are all aware of, we are just reviewing it. Who is customer? Customer, anyone who receives a product or service. That's why we have service industry and manufacturing industry. And under manufacturing, we have a huge amount of industries, sorry, manufacturing. And under service, we have also a huge examples like healthcare, insurance, banking, call center, restaurant, and so on. And customer also have two types, internal and external. Who knows the difference between internal customer and external customer? Okay, internal customers or simply employees. So, أدي كتاب. Internal healthcare providers, yes, in healthcare settings. So internal customer employees simply the physician is a customer for the lab because he is waiting for the lab test results to take a decision. Production department are customers for raw materials procurement supply chain because they cannot manufacture anything unless they have raw materials. And also they are waiting for the demand planning. They want to understand today you will manufacture X tomorrow and so on. Forecasting, demand planning and forecasting. So internal customers are simply different employees and different departments in the same organization, while the external customer is the end user who finally will receive a service, patient, or the product, the end user. Opportunity in Six Sigma means every chance to do something either right or wrong. There is no third option, right or wrong, success or failure. Success, it means every result of an opportunity that meets the customer specifications. On the other hand, defect means every result of an opportunity that fails to meet the customer specification. So, as always the case in quality in general, we are relating success and defect or success and failure to the customer specification or the customer satisfaction. So we need to satisfy our customers, whether they are internal or external. And this is always the case in all the quality three branches: design, conformance, standards, or improvement. The ultimate objective for quality as a science is to meet the customer expectations and to satisfy the customer. And Six Sigma is not different here. As we said also, Six Sigma performance implies a level of process and product performance of no more than 3.4 defect per million opportunity. And we have discussed what is DPMO in details before the break. And it is not simply related to how many defect in number of things. It's related always to opportunities or probabilities, as explained. Supplier external customers, yes, because they are outside of our organization. Correct. Azza. Yes, suppliers are external customers. Six Sigma is a philosophy about continuous improvement, simply. It's a philosophy or a culture. That's why I keep saying I don't have by necessary to have the target right first time, but at least I made improvement. That sigma level or Six Sigma level, Belifness set, which is 3.4 dpmo, if you wanted to uh, transform it or to convert it to a percentage to make things clearer for non-technical people, this equals a yield of 99.99966%, which again implies almost zero defect, which is very difficult. And the word yield, do you know what is yield? Comes from manufacturing, but also applies to service. The accepted divided by the total. Let's say I have produced 100 lamp today. 90% of them passes the quality, so it's good, accepted, while 10 are unaccepted. So I divide the accepted units, 90, by the total 100 to get a percentage, 90%. For sure, using percentage is not recommended or suggested, but sometimes it's very difficult to explain DPMO to non-technical stakeholders. So sometimes we convert it to percentage to give them an idea about how difficult it can reach Six Sigma level, while noticing that we are not asked to achieve Six Sigma level by any means, as I said multiple times in English and in Arabic before the break, because this is a huge myth about Six Sigma. And even some people in the Arab countries would say, specifically to healthcare guys, that no, this is not applicable in healthcare. We have to apply it in aviation or manufacturing. This is bullshit. Lean and Six Sigma have been applied in healthcare in US and Europe and other different parts of the world since 2000 or even 1998. Wow. Oftentimes we will see this shape. This is called the normal distribution. The normal distribution. And what we are seeing here is called the empirical rule. So what is normal distribution? In statistics, we have something called probability distributions. التوزيعات الاحتمالية. The objective of probability distribution is to show how frequently a distinct value will be repeated in terms of probability. احتمالية إن شيء معين يحصل أكتر من الباقيين. For instance, let me give you some very basic example. Do you know dice? الزهر ونرد العربية. Dice. So when you throw a dice, the dice has how many faces? Any dice has how many faces? 6 faces. And each time you are throwing a dice, the probability of getting any face is equally likely. Means from 1 to 6, you have a probability of 1 over 6. And this is called the uniform distribution. It's one of the probability distribution. Uniform, it means the possible outcomes are equally likely. They have the same probability. On the other hand, other processes like speed, like weight, like age, most of them are continuous data. They follow normal distribution. And the guy who invented this distribution, Carl Friedrich Gauss, didn't name it normal. It's called it Z. And after his death, and in honor of his name, we call it Gaussian distribution or Gauss distribution, named after Carl Friedrich Gauss, the inventor of this distribution. And some people will call it bell-shaped because it's like the bell, inverted bell. So whenever you see Z or hear Z, bell, Gauss, Gaussian, it's the same. It's simply the normal distribution. So why we call it normal after 300 years of his death? Because we realized that most of the continuous data processes will follow a normal distribution. And it shows us that as we are in the middle, there is a high probability for specific events to occur. And as we go to the extremes, the probability decreases. And this is exactly the objective of probability distribution, or in statistics, we call it probability frequency distribution. Simply tell you how your sample space or how your unique events are occurring. Do they have the same probability like the dice? And the distribution will completely different from this? Or it's follow the normal distribution or other distribution? In Six Sigma, we are interested only in the normal distribution. It's enough. We don't have to delve into the other statistical probability distributions. So simply what is happening here, this process follows a normal distribution. Then we have the mean. What we are seeing here is called the area under the curve, AUC. AUC, the American University in Cairo, which is working for? No, it means the area under the curve. And simply when you have some observations in a column in Excel, now these observations are here under the curve, just to make things clearer. And then what? Now you understand the standard deviation. So from this mean, we are traveling one positive standard deviation to the right, then 2, then 3, and the same to the left. One negative standard deviation to the left, then 2, then 3. Then we are looking into the area under the curve. And this is invented by Carl Friedrich Gauss with himself. He realized that between plus and minus one standard deviation, this part of the area under the curve equals 68% of what? Of the variation of the data. So 68% of the variation of the data is between plus and minus one standard deviation from the mean. And let's change the color. If we make it 2 and 2 here, so we are adding all of this, it becomes 95%. So 95% of the variation in the process is between plus and minus two standard deviations from the mean. And even if we increase it further to include this part, 3 and 3, so now we have also added this purple part. Now 99.73% of the variation is explained from plus to minus 3 standard deviations. And also there is 4 plus and minus 4, and it has already some percentage, and also plus and minus 5 and plus and minus 6. This is all called the empirical rule. Carl Friedrich Gauss do it. And this is the slide I think Marian shared. So let me share with you another one that shows not only 3, but share the all 6. Give me one moment. Oh, sorry, I was talking on mute. No, actually, this is not true, Azza and Muhammad. This is the definition of variation. No matter the distribution, points fluctuating around the mean, this is the definition of variation. Could be applied to normal and any other distribution as well. So what you have written here, Azza, is simply the definition of variation, not the normal distribution. This is a complete empirical rule as promised. And these first three we already discussed. That 68.27% of the data will fall between plus and minus one standard deviation, while 95 will fall within blah, blah, blah. Starting from transitioning from 3 to 4 to 5 to 6, you will realize that the increase in the percent of variation is not so worthy, if you wish. From 68 to 95, this is huge. From 95 to 98, 99, this is good. But please Note the increase in the amount of variation exposed from 3 to 4, almost zero point 0.2, from 4 to 5, almost 0.00002, then from 5 to 6, it's very minimal. That's why when Walter Sheward, Dr. Walter Sheward in 1910 invented the control chart, he relies on this. Anyone here know what is control chart or the upper and lower control limit, SPC, something like this? Just to avoid explaining something you are not aware of yet. Anyone here, few here familiar with what is control chart? If you are not, we will explain it during the course. The upper control limit and the lower control limit equals the mean plus and minus 3 standard deviation. Why 3 from here? So actually, we as statisticians, we very certain that Walter Sheward didn't invent anything. Maybe for other people who are not non-statisticians, they were impressed, but simply he stole the idea of Carl Friedrich Gauss. This is simply empirical rule. That's why when Walter Sheward defined the equations for upper and lower control limit, he used the three because it is doesn't worth to go for 4 and 5 and 6. As you can see, the increase in the amount of the variation explained is very minimal. That's why he stopped at 3. And this is a side information for you. So Walter Sheward actually didn't invent anything. He just took part of the empirical rule invented by God himself, Carl Friedrich Gauss, and invented something called control chart. Actually, he invented nothing. It has been there from 1780, 300 years. So this is the slide Mariam shared before the break, asking what has to do with Six Sigma. That I said nothing, as you can see. There is no Six Sigma here. This is the empirical rule invented by Carl Friedrich Gauss, and someone like Walter Sheward rely on it to invent something called the control chart, if you are aware of, and this explains why he used the 3, no, why not 2 or 4 or 5. Now you understand why. So the slide shared by Mariam has nothing to do with Six Sigma. It's simply the empirical rule. I hope now you understand what is normal distribution, what is the empirical rule, why Walter Sheward equations have the number 3, and all of those stuff. Any questions? Actually, it cannot be simply explained. As I said, to understand the normal distribution, you have to understand what is a probability distribution. توزيع احتمالي. What does it mean, probability distribution? First, and this is something beyond the course, but I can, if you wish, let's say our lecture ends here. Who wants to be out? Goodbye. See you next Friday, Thursday, after 2 days from now. And who wish to stay, stay as you like. This is completely not yellow belt or even close to black belt knowledge. So, what is a probability distribution? Bear with me while I'm opening an extracurricular material. Again, what I'm going to say is extracurricular means if you want to quit you can without any problems. So, what is probability frequency distribution? Hmm? Probability frequency distribution, as I said, is a collection of the probabilities for each possible outcome of an event. Let me give you an example. خليني اقول الجزء ده بالعربي بما انه هو extra curricular. I think there is no natives here, you are all understand Arabic. هعمل تجربة experiment. هجيب زهرين two dices. حلو. وهرمي التو دايسز دول، وانا interested في دراسة الصم، مجموع العدد اللي هيطلع منها. لو رميت تو دايسز، ايه اقل رقم اقدر اوصل له كمجموع؟ خلينا بالعربي اهو الموضوع عشان نسعى. معايا زهر ومعايا زهر ورميتهم هما الاثنين. ايه اقل رقم كسم ممكن اوصل له؟ اقل رقم ممكن اوصل له هو 2. بالظبط كده. ليه؟ لان اقل رقم في الظهر الاولاني واحد، واقل رقم في الظهر الثاني واحد، واحد زائد واحد يساوي 2. طيب ايه اكبر رقم ممكن اوصل له كسم كمجموع بعد ما رميت الظهرين دول او التو دايسز دول؟ 12. برافو عليك يا نهله، لان اكبر رقم 6، وهنا اكبر رقم 6. English possible. Are you a native English speaker? Can't you understand Arabic? Okay. We have an experiment. Right now, one of our colleagues asked, can you explain normal distribution simply? I said, unfortunately, that will not be getting by simple terms. We need to understand what is probability distribution in statistics. Then we can understand what is normal distribution. So right now, I'm explaining what is probability distribution or probability frequency distribution in statistics. So I have a very simple experiment. You have two dices, and each time you will throw two dices. And we are interested in the sum of what we're getting after throwing. So I asked, what is the minimum sum I can get after throwing two dices? They said 2, which is correct, because the minimum in the first dice is 1, the minimum second dice is 1. 1 plus 1 equals 2. Then I asked, what is the maximum sum I can get after throwing two dices? It's 12, because the maximum 6 and 6 there, 6 plus 6 equals to 12. This is what I have said in Arabic. Please let me know if it's clear, and let me know if you have any questions. Clear. Let's see how this will, most welcome, most welcome. Let's see how this will be transformed into a probability distribution. So first, in order to calculate the probability, we need to calculate the frequency. How many times I get sum of 2? This happened once. How many times I get a sum of 3? Twice. How many times I get a sum of 4? Thrice. And so on. Until 12, it happened once. So right now, I'm just documenting the results of the experiment in terms of frequency. How much each of those possible outcomes happened. Frequency. Then I can convert this to probability. How many possible outcomes in general we have from this experiment? And it is not 12. In statistics, we have a rule that if we have two events and those two events are independent, then the probability of getting them happening simultaneously is the product of both, the multiplication of both. So my question to you, when I'm throwing two dices, are these two dices independent or they are dependent on each other? Does the outcome of one affecting the outcome of the other or it's completely independent? It's completely independent because the outcome of the first dice is not affected by the second dice. So when I'm calculating the possible outcomes, or what we call it the sample space, I have to multiply 6 by 6, which will give me 36. Because I have multiple combinations. The number 1 from the first dice was 1, or 1 was 2, 1 was 3, 1 was 4, 1 was 5, and the same applies to 2, blah, blah, blah. So I have 36 possible combination here. So when I take the frequency 1 and divided it by 36, I get the probability of the sum 2. And then here 2 by 36 give me 1 over 18. 3 by 36 will give 1 over 12, and so on and so forth. Here I'm calculating the probability from the frequency. Probability, frequency, distribution. Probability, frequency, and then we'll see how this will be transformed into distribution. So, do all of you understand what is happening in this experiment in these three columns, starting from sum, frequency, till probability? We understand till this part? No answer. I will consider it no questions. My question to you, these are different probabilities, but do they have the same frequency? Does each probability occurring exactly like the other probabilities? Are the frequencies are constant for each probability? It is really. That's why what I am explaining right now, sometimes we don't explain it even for black belts and for master black belts. But upon your request and upon my notice, that is extracurricular and it's optional. You can attend, you cannot. But if you really want to understand the normal distribution, you have to understand first the probability distribution. If you need something much, much simpler without delving much into statistics, normal distribution is as follows. When you have any data, whatever the process, and this data is continuous. What does it mean, continuous data? It means it has decimals, 1.2, 3.5, whatever. This is the mean of continuous data. And if you took this data and you draw it as a probability distribution, 90% of the time it will give you the normal distribution. That is in the middle, most of the numbers have high probability for occurring, but on the tails, these numbers has low probability of occurring. And this applies to any continuous data, time, speed, revenue, sales, money. As long as the variable you are interested in is continuous, it has decimals. Once you draw it, it will give you the normal distribution by 90% at least. And normal distribution, on normal distribution, we can apply the empirical rule we just discussed. If I took the mean and the distance between plus and minus one standard deviation will show you 68% of the data. If you make it 2 and 2, 95%, 3 and 3, 99%. This is the most simplest I can say. Hopefully it helps. Does it help? Question mark. So the normal distribution is a probability distribution used to model and predict events if and only if it's continuous and it's following the normal distribution. As I said, the objective of the normal distribution or the benefit of the normal distribution that I can use it for prediction. I can use it for prediction, but this is a little bit advanced. We can discuss it later. For the now being normal distribution, again, it means whenever I have a variable column of data that has a continuous observations, it has decimals. If I took those numbers and draw this, it will give me something close to the normal distribution by 90%, and hence I can apply the empirical rule on it. That's why in order to apply control charts, you have to have a normal distribution or normal data. And this is the most simplest thing I can say about normal distribution. Any further questions? Statistics are not easy, just to be honest. And as long as the belts are going, the level of statistics increases. Good news that the amount of statistics in the yellow belt is from 10 to 20%. In the green belt, it's 70 to 80%. In the black belt, it's 500%. It's full of statistics. So good news for you that there is no much statistics in the yellow belt. It's just 10 to 20% of the knowledge of the course. It seems like there is no further questions and we exceeded the time, our 2 hours. Thank you so much and see you next Thursday, inshallah, to continue what we have started. All the best.